Dear students, in the last class we have learnt about an important two-dimensional motion, which is projectile motion. And when a body is projected at a certain angle, its trajectory is a parabola. So, what is the equation for the trajectory of a projectile? So, that is what we are going to derive. This is an important derivation. So, a lot of mathematical forms are there. So, concentrate, listen and try to understand the each steps that I am going to explain. So, first I am going to consider an axis. We need the two axes, one the x axis, the other the y axis, because it is a two-dimensional motion. And now, from the point O, a body is projected so that its path is a parabola. This is the trajectory. It starts from O and then it reaches C. And when it is projected, it has to be projected with a certain velocity, and that velocity is called velocity of projection. And that velocity of projection makes an angle theta with the horizontal. The theta can be 0 degree, it can be 1 degree, 2 degree, any degree, it can be even 90 degree as well. So, theta varies from 0 to 90 degree. Now, this particular vector which is there, u, can be resolved into two components, one along the horizontal, which is here, resolution of the vector, splitting of a vector into two components. So, since it is along the horizontal, since it is along the x axis, it is taken as a ux, and what is that ux is equal to u cos theta. Along the vertical, it is a uy, that is uy, because u stands for initial velocity, correct. Y stands for axis along the y axis or along the vertical direction, it is a u sin theta. So, therefore, this is the initial velocity along the horizontal, this is the initial velocity along the vertical. So, here what is the initial velocity along the horizontal? It is ux. What is the velocity here? It is uy. Okay. Now, after certain time, as the at t is equal to 0, it is here. After certain time, it reaches a point P. Okay. After certain time, it reaches a point P. By then, it covers the vertical distance of y and horizontal distance x. Hope you understood this. By then, when it reaches point P, it has already covered some horizontal distance. What is that equal to? That is equal to x. Along the vertical, it has covered y. Now, let us take two separate motion, one along the horizontal, other will take along the vertical. So, first I am going to consider only along the horizontal, okay, along horizontal. Along the horizontal, what is the initial velocity? Initial velocity is equal to u cos theta. And we already learnt the basics of the projectile. Along the horizontal, there is no acceleration. So, acceleration is 0. There is no acceleration. Time taken will be definitely t. Time taken will be equal to t, correct. So, what is the distance travelled along the horizontal? It is x. Hope you understood this. This is the velocity, initial velocity. This is the acceleration, there is no acceleration. What do you mean by no acceleration? The body moves with the uniform velocity, okay. And t is the time taken. What is the distance? Distance is equal to x. So, now if I use s is equal to u x t plus half a x t square. You know this formula, right? S is equal to ut plus half a t square. Why I am writing ux? Because now we are writing the equation only for horizontal motion. Okay. So, what is s? S is nothing but x is equal. What is ux? U cos theta. Into t. What is ax? 0. Therefore, this term becomes 0. So, this is one of the equation which you have to remember. From this, I can rearrange that t is equal to x by u cos theta, x by u cos theta. So, we need this later for the substitution. Are you clear with this first equation? Okay. Next, along the vertical, that's along vertical means y axis now. Okay. So what is uy? Uy is u sin theta. What is the acceleration? Ax. See, it's going upward, right? And along the vertical, there is acceleration, which is acceleration due to gravity. Since it is going up, it's minus g. Okay. Time taken is a t, and s is equal to y. Vertical distance traveled. So use the same formula, right? S is equal to uy t plus half ay t square. S is nothing but y. This is u sin theta into t. Minus, that minus because of this, okay, minus half g t square. Clear? So that is y is equal to u sin theta into t is here, we have rearranged, right? So substitute that x by u cos theta minus half g into square of this x square by u square cos square theta, u square cos square theta. So this u will get cancelled. Sin theta by cos theta is nothing but tan theta into x minus g by this 2 in the denominator, okay, 2u square cos square theta into x square. So we got some equation, y is equal to tan theta into x minus g by 2u square cos square theta into x square, which I can write like this, y is equal to ax minus bx square, where a is a tan theta and b is equal to g by 2u square cos square theta. Why I am replacing this as a and b? Because for a given angle, a is a constant. For example, if theta is 45 degree, then tan 45 is 1, which is a constant. G is a constant, 2 number constant. Again, for a given velocity and for a given angle, this a and b are constant. So that's how we get y is equal to ax minus bx square. So you must have learnt in your lower classes, that is y is equal to mx plus c. It represents a straight line. There is an equation representing a straight line. Similarly, y is equal to ax minus bx square. It represents a parabola, a structure called parabola. This is a parabola. So therefore, what we have proved here is that the trajectory of a projectile is a parabola. So that is what the question will be. Prove that or show that the trajectory of a projectile is a parabola. So, and this is what you have to write. So you have to write two separate motions. You cannot combine together. Either apply along the horizontal or apply along the vertical and then try to relate them. Okay. So hope you understood the y along the horizontal is 0, because we know that the body moves with a uniform velocity along the horizontal. Along the horizontal, there is no acceleration, there is no force. Okay. The force is only vertically downward, because of the gravitational force. It's not along the horizontal. That's why no acceleration, no force along the horizontal. Okay. But there is a force, there is acceleration along the vertical. That's why I've written it as minus g. So this is an important question from the exam point of view. So it has appeared again number of times in the exam. Now based on this, we can get the equations for maximum height, we can derive expression for time of flight, we can even derive expression for the range of the projectile as well. So all these derivations are important. They are repeatedly asked questions. So let's first derive expression for maximum height. Expression for maximum height. For which, as usual, I am going to consider the two axes, then the trajectory of the projectile, the initial velocity, that is the velocity of projection, and the angle of projection, and then the components. Okay. And now, what is maximum height? Maximum height is one where the projectile reaches here, and this becomes the maximum height, correct? Which we denote by h. So, what is the initial velocity along the vertical? Because when we say maximum height, it's along the vertical, correct? What is the final velocity along the vertical? What is the acceleration along the vertical? What is the distance along the vertical? Okay. So, what is the initial velocity along the vertical? Because everything, why we are considering only y-axis? Because this height is measured along the y-axis only, right? So, that is why everything along the y-axis. So, what is the initial velocity along the y-axis? That is u sine theta. U sine theta. And now, when the projectile reaches here, that is the maximum height here, point P, the velocity is exactly along horizontal. It will be like this. Okay, see, that is the velocity along the horizontal. So, there is no velocity along this. So, final velocity along the vertical at P is 0. Hope you understood. This is the initial velocity here, correct? Which is u sin theta. But here, the velocity is exactly horizontal. When the velocity is horizontal here, there is no vertical velocity, correct? So, that is why Vy is 0. What is the acceleration going up? Minus g. What is the distance traveled, when it reaches from here to here along the vertical, which is h, maximum height. And that is what we have to calculate. So, hope you understood. So, uy is a u sin theta, initial velocity along the vertical is u sin theta, and when it reaches here along the vertical, there is no velocity because the velocity at point P is exactly horizontal, that is why it is 0. And what is the acceleration upward? Minus g. What is the distance displacement along the vertical? It is h. Now, which is the equation that relates to all these variables? That is v square is equal to u square plus 2as, everything along the y-axis. So, what is the final velocity? 0. What is the initial velocity? U sin theta, square it, u square sin square theta, minus, that is because of this, okay, 2gh. So, bring this to the left, 2gh is equal to u square sin square theta, right. So, what is h then? H is equal to u square sin square theta by 2g. So, this is the expression for the maximum height reached by the projectile. So, what is the maximum height? The expression for maximum height is given by h is equal to u square sin square theta by 2g. I hope you understood how we get it. We have to make use of the equations of motions from the previous chapter. Okay, v square is equal to u square plus 2. Everything along what axis? Y axis. Why? Because height is measured vertically. So, we have to consider only one type of motion, which is vertical motion. So, what is the formula for maximum height? H is equal to u square sin square theta by 2g. Again, using the same method, I can find the time of flight. So, first I am going to consider the projectile motion as usual, the two axes, the projectile path, the direction of the velocity, the angle of projection, the components along the vertical, and then now let us consider the point P. Okay. Now, I want to find the time taken by the projectile to move from O to P, from here to here. It is called time of ascent. So, what is the initial velocity along the vertical? It is u sin theta. When it reaches point P, what is the vertical velocity, final velocity? It is 0. What is the acceleration along the vertical? It is minus g. And then I am going to find the time. Now, which is the equation that relates v, u, a and t? Recall from the equations of motion, it is v is equal to u plus at. Everything along y axis. Okay. What is Vy? It is 0. What is Uy? U sin theta minus g into t, minus g into t. So, gt is equal to u sin theta. So t is equal to u sine theta by g. Now that is called time of ascent, time taken to reach from here to here. Time of descent is also same, that is to move from P to C. So this is equal to time of ascent or time of descent. What is time of flight? Time of flight is nothing but twice this time, correct? Now we have to add time of ascent plus time of descent is nothing but the time of flight, correct? So therefore 2t, that is a t is equal to t, we know it, so it's twice, so 2u sine theta by g. So this is the expression for the time of flight of a projectile. What is the expression for maximum height? H is equal to u square sine square theta by 2g, and now time of ascent is t is equal to small t is equal to u sine theta by g, and time of flight is double that value, which is capital T is equal to 2u sine theta by g. So this is again another derivation. All these derivations are important because they are all the derivation that have appeared in the previous exam. That is trajectory of the projectile, the height of the projectile, the time of flight, even the next, which is about the range of the projectile, the range. To find the range of the projectile, and again you can see the diagram is the same for all the so this is about the range of the projectile. So consider again two axes, the trajectory, the direction of projection, the angle of projection, and the vectors. Okay. Now what's the range? The maximum horizontal distance covered is called as the range, that is from here till here, denoted by r. So now keep in mind, now everything about the horizontal motion we have to consider because we are measuring the horizontal distance. So now along the horizontal, okay, what is the initial velocity along the horizontal? Okay, it is u cos theta. What is the distance traveled along the horizontal? That's called as the range. What is the time taken for it? Time taken is called the time of flight. Time taken to describe the range is called the time of flight, right? That is the initial velocity. Okay, what is the acceleration along the horizontal? It's a 0. There is no acceleration, right? So now use S is equal to ut plus half at square, everything along the x-axis. Okay. What is Sx? It's r. What is the ux? U cos theta into what is the time taken is a time of flight plus this term is 0. Why? Because the x is 0, right? That's r into u cos theta into what is the time of flight? Time of flight is we know the formula already, correct? T is equal to 2u sine theta by g. 2 into u square. Then we have sine theta into cos theta by g. Okay. Now this is one of the format of the range. The other format is, see here we have a formula called 2 sine theta cos theta. So you need to remember one more formula, that is sine 2 theta is equal to, let me write here, sine 2 theta is equal to 2 sine theta into cos theta. What is sine 2 theta? 2 sine theta cos theta. So that's why you can even write like this, that's equal to u square sine 2 theta by g, because 2 sine theta cos theta. 2 sine theta cos theta is nothing but sine 2 theta. You will be learning the explanation of this in mathematics, but for timing you remember the formula here, sine 2 theta is equal to sine theta cos theta. So that's why you can even write u square sine 2 theta by g. So this is the third important formula, that's for the range, and based on this we have numericals. So that's why these equations are important. Even to solve problems also you have to learn all these formulas by heart. Now how to remember things? Repetition. Only by repeating the same thing again and again and again you will be able to remember all these formulas. Okay. So be serious about your preparation. So most of them they are neglecting the studies, they don't study on the daily basis. and that is why your performance is very bad in all the tests. So, study on daily basis, write and study, utilize some time for the preparation for the exam, for the various subjects, and stop wasting your time on the Facebook and the Instagram. Okay. So, that is the third important formula. So, just very quickly we will recall what I have derived in today's class, and in the next class I will solve problems based on these equations. Okay. So, the first one that I had derived was y is equal to x minus bx square, where a is tan theta and b is equal to g by 2 u square cos square theta. The next important formula was for time of Sn, t is equal to u sin theta by g, and then the time of flight is double that, which is a 2 u sin theta by g. After that, for maximum height, h is equal to u square sin square theta by 2 g, and then the important one, the range, which is r is equal to u square sin 2 theta by g. That sin 2 theta you can even write it as a 2 sin theta cos theta. So, these are all important set of formulas, and based on this let us solve numericals in the next class. So, that is why be ready with the preparation, only then you will be able to understand the numericals. So, first you have to study the theory, only then you will be able to understand what is the numerical is all about, or how to solve these numericals, otherwise you will not understand. Okay. Right. So, start writing the notes. I will be verifying the notes on next Monday, and keep your notes ready. I will check, and then we will have one interactive session soon, and after that we will be having test in this particular chapter.